general tendency about the lead for the, maybe for the land resource manager or forest owners. Wondering if we should go for lead, we should go for logging, or maybe there's an opportunity for lead. And for the logging, yes, we need the jobs and we need the development. We want the development. Often the logging, the operation brings you the schools, the road, and the hospitals. And yes, of course, we want the money as well. We need the money. We have resources. We want money. But on the other hand, yes, the environment is important. We want our clean water. We still need the clean water running. We don't want a disaster happen, landslide. We don't want that. So environment is also important for us. And also, I want to think about my children and my grandchildren, so future generations. That's important too. And some people saying, we might get the carbon money to just keeping this forest intact. Here I know all of you are lead experts, so the lead is not just conservation, but many functions. But I think there's this kind of general, the way of thinking about the lead. So today, I would like to show you the example of what exactly happening for the forest carbon during the logging operation. So our study area is in Papua New Guinea, in the Morobe province. Mongibushka Forest Management Agreement area, 51,000 hectares. This area, the annual precipitation is 4,400 meters, very wet area. But you can see that we have a very big tree there. This is the Pomecia pinnata. Diameter is about 2-3 meters. And this is called Taba in Samoa. And in Fiji, called Dawa. But in Fiji and Samoa, this tree doesn't grow. This research area is a permanent sampling plot system. So we have all the trees above 5 cm is marked and identified species, and measured, and even all the coordinate of trees are recorded. So we know exactly where trees are. We harvested 37 trees, and the largest trees we had is 78 cm. Yes, Dr. Kyono mentioned we need to have big trees for sampling, and Patrick also mentioned that, and I totally agree with that. But this 78 tree was big, but now I'm thinking we need, especially for PNG, we need a lot bigger trees and more number of the sampling of big trees to have a strong the model. So we use this model to estimate the forest carbon. And this is in the 1 hectare plot. There was 945 trees of PBH 5 cm and above. And then you can see these green circles. These are the trees actually cut. And those X mark, these are the trees destroyed during the logging operation. So when the loggers cut the big trees, many small trees are also, they're felled, and sometimes for the preparation, setting up the skipping track, many trees are destroyed. So these axes are the trees destroyed during the operation. So the 17 trees are harvested. Those trees are all PBH about 50 cm, which is according, they follow the logging code practice PMG. And for harvesting 17 trees, 301 trees were destroyed. And so 627 trees are remaining. This is a kind of typical range of typical, the conventional logging. For the conventional logging, and there's some studies in Asia, Southeast Asia, about 10 to 15 trees per hectare is harvested, and the PNG as well. So about 10 to 15 trees, harvested for the conventional logging. So we have 17 trees harvested in 1 hectare. So this is like a slightly heavier type of the logging occurred in just this 1 hectare. So this is a proportion of harvested, and so here, one example in Buloro, this is the alkali dominant forest. 20% of trees are harvested, then only about 20% trees are remaining. So you cut in only 1/5 of trees, but this pretty much total, the destruction forest, so total deforestation. And yeah, so our case is related. We have 2% is harvested, but the number of trees remaining is about 66%. So this is what happened to our trial site during the logging. Then I would like to show you what happened to the forest carbon. Our carbon map, we are confident that we have the most accurate possible way to estimate our forest carbon. We have our own site-specific models and all the different tree species and each the tree component, branches, leaves, and they are all carbon is actually analyzed, was actually measured. So we often say carbon is about 50% of the biomass is carbon, but in our case it was like 44 to about 50%. So this is with the most accurate carbon estimate we can have in the forest. So we had 196 tons of carbon in above ground biomass. And then during the logging, 20% of the carbon is actually taken out from the forest for the processing. So from here, I don't know the recovery of the wood. So if 50% of the wood is utilized, so once the wood is some timber or whatever, then you build a house or whatever, furniture or anything, then it will remain in the wood body. The carbon is remain in their body, and so the carbon is not immediately emitted to the atmosphere. Even this 20% of carbon is taken out from forest, but not emitted to the the carbon was destroyed in the forest, but left in the forest, not taken out from the forest. So like those, this is not a picture of the Bushiga, this is the Durawa in Fiji. The challenge is measuring those lying deadwood. But these lying deadwood, they stay there for many years sometimes. So these are also not emitted, those carbon in deadwood, they are not immediately emitted to the atmosphere, still there in the forest. And these stay longer, but they're small fraction, like fallen leaves, canopy component, fallen leaves, and branches and these, they are relatively quickly decomposed. But this carbon decompose. This is a graph after 1 year, one and a half year after logging at the site. You can see the logged over organic carbon is significantly higher than the undisturbed or before logging. So during the logging, because of lots of the carbon deposited to the forest floor and they decompose, then the soil carbon is increased, significantly increased. So some of the carbon transferred to the soil. So often we are saying like about 50%, because of the logging, about 50% of forest carbon in the above ground biomass is lost. But actually, I don't know how much actually really released to the atmosphere, and also when those carbon is released to, it takes time to release the atmosphere. During that time, these logged over forests accumulate, the carbon from air to their body, increase the carbon stored in the forest. So maybe it could be only small portion of the forest carbon is emitted to the atmosphere as a result of logging. Well, we need to have a more study, but yeah, this showing it's not just okay, when we cut the forest, all the carbon in the forest is going to the atmosphere. It's not the case.